Okay, in number 23, we begin to look at some of the word problems in Chapter 1, Section 5. So, the total cost, C, in dollars, to participate in a ski club is given by the literal equation C is equal to 85x plus 6. So, C is equal to 85x plus 60, where x is the number of ski trips you take. So this is an example of, for perhaps there is a $60 initial fee regardless of how many trips you take, and then there is $85 fee for each ski trip that you go on. So what we want to do in this problem is to solve this equation for x. So we're going to subtract 60 first on both sides. Remember, the goal is to isolate the x, and when we do that, we end up with C minus 60 is equal to just 85x, and then following that, we can divide by 85 on both sides. So we end up with x is equal to, of course we get lots of things canceling there, and we get x is equal to C minus 60. That is the total cost of the trip. Take away $60, which was the one-time non-refundable fee regardless of how many trips you take, and that amount will tell us, when we subtract 60 from the total cost, will give us a number that is a multiple of 85. And so when we divide by 85, we're going to get how many ski trips the person went on. So we did A, which is to solve that equation for x. How many ski trips do you take if you spend a total of $315 or $485? Well, let's see. Let's use this formula. We could go back to the original formula and plug in, but this one is probably a lot more convenient. So if I started with x, I'm trying to figure out how many trips I would take if the total cost was $315. So I would plug or substitute 315 for C. Then I'm going to get my calculator ready, and I'm simply going to divide 315, or calculate 315 minus 60 is equal to 255, and then 255 divided by 85 is 3. So in that case, I would say that I'm taking 3 trips would cost $485. The second equation, well, what would happen if I spent $485? How many trips is included in that? And you may, just by looking at that, be able to tell that, well, if 315 was 3 trips, add 85 we'll get up to 400, add another 85 we get up to 485, and so we would have, this one should give us 5 trips. I'm going to bring up the calculator, clear 485 minus 60, we take off the one-time fee, now we have $425, divide that by 85, and we do indeed get 5 trips. So the first one is 3 trips for $315. The second one is 5 trips with one S for $485. And that concludes this problem. We'll go on to number 24. Okay, in number 27, 28, and 29, we're given some specific formulas and we want to solve for a particular variable. So the first one, 27, we know that 27, we do know that profit is equal to revenue minus costs. And we don't have to worry about exactly what those mean right now, but our goal is to solve for C. So the first thing that we could do is leave the C alone and subtract an R on both sides, and we'd get P minus R is equal to negative C. However, because that negative C is not the final form that we want, we're going to multiply it by negative 1, multiply the other side by negative 1, and what that's going to do is change all of the signs. So the P becomes negative, the R becomes positive, the C becomes positive. So we might say then, rewriting, C is equal to R minus P. It's the revenue minus the profit that gives you your costs. All right, number 28. We have the surface area of a cylinder being S is equal to 2 pi r squared plus 2 pi r h. Again, we don't need to explain what all of those mean right now, but our goal is to isolate the h. So we're going to deal with addition and subtraction. Before multiplication and division, subtract negative 2 pi r from both sides, and that gives us S minus 2 pi r squared, if I didn't say that correctly, is equal to 2 pi r h. And at this time, the easiest way to isolate the h is to divide both sides by 2 pi r, and we've come up with our final form after we cancel of h is equal to S minus 2 pi. Okay, sorry for the bell sound there. We ended up with S minus 2 pi r squared all divided by 2 pi r, and it might be tempting to try to cancel some things in there, but that's fine to leave that in that form. Alright, with the final example, we have the area of a trapezoid. Sorry once again for that. Alright, so we start with the area of a trapezoid being 1/2 the height times the sum of the bases. And we want to solve this for B2 this time, not for H. We've solved this before, previously, for H. So before we can do anything else, I would still suggest that you get rid of the fractions by multiplying by the reciprocal. So we end up with 2a is equal to H times B1 plus B2. Now, at this point, with our goal being to isolate B2, we could do a couple of things here. We can divide both sides by H, and we would get 2a over H is equal to base 1 plus base 2, and then we can subtract base 1, and you would end up with, now the way we write this looks a little complicated, 2a over H, then it's a minus base 1 out by itself over there is equal to base 2. Another thing that we could have done with this particular one, and I don't want to spend too much time on that, but just so that you can see, and if you're at a point where you can learn from this, then that would be great. So I'm going to scroll down just a little bit. And what we could have done first, after we multiplied both sides by 2, would be to distribute the h to the B1 and B2. Actually, I'm going to take that back, and we're just going to stop this one at this point here. This is good enough for what we need right now. That's a really complicated one, and I don't want to go too far off on the complicated problems. But there are other ways of solving that. They may not look exactly like that when we're done, but as long as you use the correct properties of equality, adding and subtracting the same thing to both sides, multiplying and dividing, then you will come up with a correct form of that answer. And we're going to stop this video at this time.